Hi, this is Mrs. LaBarbara. This is Physics Chapter 8, Video 2. Today's topic is charge interactions, conductors, and insulators. The objectives are to know charge must be conserved in all interactions between objects. Conserved means to stay constant. You also need to know the difference between conductors and insulators. You need to understand objects with like charge repel. Objects with unlike charge attract. Also, this is charge interactions. Also, that neutral objects are always attracted to any object with charge. That means neutral attract to the negatively charged object, and neutral is also attracted to the positively charged objects. The way charge redistribute on a conductor is to minimize the repulsive force. So that's the difference between conductors and insulators. You need to be able to determine the charge on an object based on description of tests using charged rod or other objects, and be able to determine the final charge on two or more objects after they interact using the law of conservation of charge. First, let's investigate charge interactions. So electric force is a non-contact force. That means you can feel the force without touching. Any object that can exert this force, any charged object can exert this force on other objects, both charged and uncharged. So there are two types of interactions. The first is attraction, the other one is repulsion. Let's see, attraction exists between oppositely charged objects. If you put a negative charge and a positive charged object, they will attract each other. Another is the attraction also exists between charged and neutral objects. So if one is neutral, not charged, the other one is charged, they will attract each other. The charged object can be negative or positive. The other type of interaction is repulsion. Repulsion occurs when you put two likely charged objects next to each other. Positive and positive repel, and negative also repels another negative. Electric force and Newton's third law. Remember, Newton's third law says for every action, there's equal and opposite reaction. And that means the force can only exist in pairs. The two forces are acting on two different objects. That's why they don't cancel out. So electric force exerted between two charged objects or between a charged and neutral object is a force in the same sense that as a friction force, tension force, gravity or air resistance, and other forces. So, and being a force, the same law and principle that describes any force describe the electric force. One of those laws is Newton's third law, that's action-reaction. So here's other balloons. The balloon, if they have the same charge, they will repel each other. And the force on A will be the same as the force on B. Those are action-reaction forces, acting on the different object with the same magnitude and opposite direction. If you put two opposite charges next to each other, they are also exert the same force, same amount in the opposite direction. One on C and one on D, they are the same magnitude and opposite direction. Similarly, if you put a charged object next to neutral object, they will attract each other, and the force on each would be the same as well. Interaction between charged and a neutral object. So any charged object, whether positively charged or negatively charged, will have an attractive interaction with neutral object. We talked about this. This is just kind of emphasize the interactions between charge and neutral is attractive force. According to Newton's law of reaction, action-reaction, the neutral object attracts the charged objects, and so is the charged object attract the neutral object. Charge detection. How can we determine charge? So if the two objects repel each other, we can conclude that they must charge with the same types of charge, but we cannot conclude how much, or if they are positive, both positive or both negative. If the two objects attract each other, we can conclude that at least one of them is charged, because they can be oppositely charged or one is charged. So at least one is charged. Let's take a look at this example. A lightweight sphere hangs by an insulating thread. A student wishes to determine if the sphere is neutral or electrostatically charged. So she has negatively charged hot rubber rod and positively charged glass rod. She does not touch the sphere with a rod, but runs tests by bringing them near the sphere one at a time. The student notes that the sphere is attracted to both rods. This test results show that the charge of the sphere has to be neutral because only neutral objects attract both positive and negative charged objects. Another example, a negatively charged plastic comb is brought close to but does not touch the small pieces of paper. If the comb and paper attract to each other, the charge on the paper may be negative or neutral, may be positive or neutral, must be negative or must be positive. See, because the comb is negatively charged, so a negatively charged object can attract a positive charged object or neutral object. So the answer is 2. The law of conservation of charge. So far we have learned the law of conservation of momentum and the law of conservation of energy. So here is another conservation law, is the law of conservation of charge. So the law of conservation of charge means the charge in a system, in a closed system, remains constant. So if the two objects together has a positive 2, say electrons, so they can interact, they can touch each other, you can put them next to each other. So after this interaction, the charge after the interaction is the same as before. So that's what the conservation means. Conservation means constant, remains constant. So let's take a look at this example. The diagram shows 4 charged metal spheres suspended by strings. The charge of each sphere is indicated. If the sphere ABC simultaneously comes into contact, the net charge on the spheres will be, so before, let's see, +5, -3, +2, and -1. So your net charge is +3, right? That's -2. That's +2. A +5, -3 give you +2. Another +2 give you +4. Then you have -1 give you +3. So before the total is 3, after our total has to be +3 as well. Another example, so during physics lab, a plastic strip was rubbed with cotton and becomes positively charged. The correct explanation for why the plastic strip becomes positively charged is that the plastic strip acquires protons. We know protons cannot move, so this cannot happen. The plastic strip acquires extra protons. It can acquire extra protons because protons does not move from cotton. Okay, protons were created. Nothing can be created. So the plastic strip becomes positively charged because it's lost the electrons. Only electrons can move. So the answer is D. Okay, now let's take a look at conductors and insulators. So some materials are conductors, some materials are insulators. You probably have experience in your home, even in school, you know, you'll have to connect wires for the lights to work, and the wires has to be conductors. So what are the conductors? Conductors are material that permit electrons to flow freely. So in order to have electricity, electrons must move. So the conductors is material that permit that to happen. In contrast, the insulators does not allow the material, the electrons to move in that specific material. So this is a picture of an insulator. Electrons will stay put. It cannot move. It's not allowed to move. Now for a conductor, electrons can move evenly, going everywhere. So a charge on insulator will remain at the initial location. So here is the insulator. If somehow I put a negative charge at this spot, the charge will still be at this spot an hour later. It will not move. On the other hand, if I put a negative charge on this spot on a conductor, they will quickly spread out. So the charge on a conductor is quickly distributed across the entire surface of the object. So why does charge distribute evenly on a conductor? Why does that happen? Why does charge, we know the electrons can move. Why does it move evenly? So this is why. So an object made of conducting material will permit the charge to be transferred across its entire surface of the object. So if charge is transferred to an object at a given location, that charge will be quickly distributed across the entire surface of the object. The distribution is the result of electron movement. It's not a proton, only electrons can move. But why is that? Since conductor allows electrons to be transported from particle to particle, the charged object will always distribute its charge until overall repulsive force between the excess electrons is minimized. That is why, because it's want to minimize the force between everything. So all the net force on each one becomes a zero. So it can't move anymore. Okay, that's why, to minimize the force. So let's take a look at this example of conductors and insulators. So some materials are conductors. The common ones are metal. We know the wires are made of copper, which is metal. Aqueous solutions of salts, graphite, water is conductor, so is human body. Take a look. This is called Van de Graaff generator. We probably will show you in class. So Van de Graaff generator can be charged using a belt in here. So when it is charged and the person is touching it, that extra charge will connect to the person and that charge will redistribute. See, all the hair is going to be separated. That's because like charge repel each other. This is repulsion of the hair. That's the result. So human body is a conductor. On the other hand, insulator are plastics, styrofoam, rubber, right? That's why we put rubber around the copper wire to prevent people getting being charged, glass or dry air. So you probably have experience in the winter, you are more likely to accumulate charge on your body. That is because when you walk across the, say, carpet, there's charge going to be accumulated on your body. So because in the winter, the atmosphere is very, very dry, so that charge is going to remain on your body. So that's why when you touch something metal, you get shocked. Now in the summer, the air is humid. There are many water molecules. And what water molecules does is to take this excess charge in your body away. So your body remains neutral, more or less. So insulators and conductors, there is not a definite separation. So this division is artificial one. And somewhere in the middle, we call this semiconductors. Let's take a look at check your understanding. Suppose that a conducting sphere is charged positively by some method. The charge is initially deposited on the left side of the sphere, yet because the object is conductive, the charge spreads uniformly throughout the surface of the sphere. The uniform distribution of charge is explained by the fact that the charged atoms at one location moves throughout the surface of the sphere. No, atoms does not move. The protons does not move either. The only thing that moves is the electron. So the answer is C. The electron moves because it is attracted toward the other side of X. Hi, here is another example. So check your understanding. The conductor differs from the insulator. It doesn't have anything from A to E. The answer is F. That's it. Okay. Thanks. That's proton. That's it. That's it for today. Thanks for watching. See you next time.